What if nature followed hidden rules? What if every falling object whispered? What if the universe obeyed mathematics? One curious man pursued those answers. His name was Isaac Newton. He changed humanity's understanding of reality. Yet his journey began without glory. Newton was born during troubled times. England suffered conflict, fear, uncertainty. His father died before Newton's birth. His mother later left him behind. Young Isaac grew quiet and isolated. He spent hours observing everything carefully: shadows, wind, water, and moving clouds. Ordinary things became fascinating mysteries daily. Why did objects move as they? Why did stars remain above Earth? Why did planets never simply fall? Nobody possessed complete answers then either. Ancient ideas still controlled scientific thinking. Many believed Earth occupied creation's center. Others trusted traditions more than evidence. Newton trusted questions nobody could answer. His curiosity became his strongest companion. At school, Newton appeared strangely distant. He preferred building models and machines. He created small wooden mechanical devices. He watched nature with endless patience. Some classmates underestimated his unusual mind. Newton remembered every insult and challenge. Determination slowly replaced his childhood loneliness. He began studying with fierce discipline. Books became doors toward hidden worlds. Mathematics became his private language eventually. Numbers revealed patterns beneath visible chaos. Newton entered Cambridge seeking deeper knowledge. The university offered ancient philosophical teachings. But Newton wanted something far greater. He studied new ideas secretly nightly. Galileo's discoveries inspired his restless imagination. Kepler explained planets through mathematical patterns. Descartes challenged traditional ways of thinking. Newton absorbed every powerful idea eagerly. Then England faced another devastating crisis. A deadly plague spread across cities. Cambridge suddenly closed its crowded doors. Students were forced returning home immediately. Newton left university without knowing why. His greatest discoveries were still waiting. He returned to the quiet countryside. Woolsthorpe offered silence beyond crowded classrooms. There, Newton worked almost completely alone. No famous teachers guided his research. No audience applauded his difficult questions. Only nature remained before his eyes. Days passed beneath changing English skies. Newton studied light, motion, and mathematics. His thoughts became increasingly bold and dangerous. Could nature obey universal mathematical laws? Could one force control distant planets? Could falling objects reveal cosmic secrets? These questions followed Newton everywhere constantly. Then one ordinary moment changed everything. An apple fell beneath a tree. Newton looked upward, beyond the falling apple. The apple struck the ground silently. Newton watched its simple downward journey. Everyone knew objects naturally fell downward. Yet Newton asked a different question. Why did the apple fall downward? Why not sideways, upward, or nowhere? Something invisible pulled the apple earthward. But how far could that force reach? Could it extend beyond clouds and mountains? Could it reach the distant moon? Newton imagined the moon constantly falling. Yet the moon never struck Earth. Its sideways motion kept missing Earth. Gravity pulled while motion carried forward. Together, they created endless orbital movement. Suddenly, Earth and heaven seemed connected. The same force governed apples and planets. Nature no longer appeared divided completely. One invisible law connected everything together. Newton felt possibility become mathematical certainty. However, imagination required difficult calculations. He needed mathematics beyond existing methods. Therefore, Newton developed powerful new tools. He created methods later called calculus. Numbers could now describe changing motion. Curves revealed hidden rates and forces. Complex problems slowly became understandable mathematically. Newton worked through endless sleepless nights. Papers covered every table and floor. Candlelight burned beside unfinished calculations. His thoughts moved faster than language. He wrote ideas using private symbols. Few people understood his strange methods. Newton cared little about their approval. He wanted nature's deepest answers instead. Meanwhile, sunlight entered his dark room. Newton noticed something strangely beautiful there. White light passed through clear glass. A prism separated colors across walls. Red, orange, yellow, green, blue appeared. Newton realized white light contained colors. The prism created no colors whatsoever. It merely separated hidden colors already. This discovery challenged accepted scientific beliefs. Many scholars doubted Newton's strange conclusion. Some accused him of misunderstanding light. Newton repeated experiments with greater precision. He blocked sunlight through tiny openings. He used prisms inside dark rooms. Every experiment produced similar results again. Evidence slowly strengthened his controversial theory. Newton learned observation defeated confident assumptions. Still, another mystery demanded his attention. How exactly did objects begin moving? Why did moving objects eventually stop? What happened when forces collided together? Ancient explanations offered confusing answers repeatedly. Newton believed motion followed precise laws. He imagined bodies moving through empty space. Nothing would change their motion naturally. Only an external force caused change. This insight became his first law. Nature suddenly appeared orderly and predictable. But Newton had only begun searching. 3 laws would soon reshape human knowledge. Newton began organizing his revolutionary ideas. Motion became numbers, patterns, and laws. His first law described natural inertia. Objects resisted changing their current motion. Rest remained until forces caused movement. Motion continued without opposing forces present. This idea challenged ancient beliefs deeply. Aristotle claimed motion required constant force. Newton showed motion could continue naturally. The universe suddenly seemed more mechanical. Every movement followed understandable mathematical relationships. Then Newton examined changing motion carefully. Greater force produced greater acceleration naturally. Greater mass resisted acceleration more strongly. These relationships formed Newton's second law. Force became mass multiplied by acceleration. A simple equation described complex movement. Yet Newton's thinking continued moving forward. He studied collisions between moving objects. Every action created an opposing reaction. Forces always appeared in equal pairs. Push a wall and walls push. Fire a cannon and recoil follows. Row a boat and water responds. Newton's third law explained these interactions. Nature never allowed force without response. Every movement created consequences somewhere else. The universe behaved like connected machinery. Newton believed mathematics revealed nature's language, but understanding required proof and evidence. He tested ideas through difficult calculations. He compared predictions with observed movements. Planetary paths became his greatest challenge. Kepler had described their orbital patterns. Newton wanted explaining their hidden causes. Why did planets follow curved paths? Why did they never escape outward? Why did they never fall inward? Newton returned to his gravity idea. Perhaps gravity weakened across greater distances. Perhaps distance followed a precise pattern. He calculated using Earth's enormous size. Then he compared results with lunar motion. The numbers seemed astonishingly close together. Yet small errors troubled Newton deeply. His measurements required greater accuracy first. He temporarily abandoned the difficult calculation. Years passed while questions remained unanswered. Newton continued studying mathematics and light. His reputation slowly grew across England. Cambridge eventually welcomed him as professor. Students expected clear lectures and guidance. Newton often spoke to nearly empty rooms. His ideas seemed difficult and strange. Sometimes nobody attended his lectures whatsoever. Newton continued teaching despite lonely silence. Meanwhile, scientific debates grew increasingly intense. Scholars argued about gravity and motion. Some demanded stronger mathematical explanations immediately. Newton avoided public conflict whenever possible. He preferred working privately without interruptions. But destiny soon interrupted his isolation. A famous visitor brought urgent questions. His request reopened Newton's forgotten calculations. The universe was about to change. One day, Edmund Halley visited Newton. Halley carried questions about planetary motion. He asked why planets followed ellipses. Newton answered with surprising confidence immediately. Gravity created those curved celestial paths. Halley asked for mathematical proof then. Newton searched through his old papers. The proof had disappeared somewhere mysteriously. Newton promised rebuilding every calculation carefully. That promise awakened his deepest obsession. He returned to mathematics with fury. Days disappeared inside endless calculations quickly. Nights passed beneath weak candlelight silently. Papers covered tables, chairs, and floors. Newton barely noticed hunger or exhaustion. His mind pursued nature without mercy. He calculated forces across enormous distances. He studied falling bodies and planets. The same equations connected both worlds. Earth and heaven followed identical laws. Newton finally solved the ancient mystery. Gravity weakened through the inverse square. Distance determined gravity's changing strength precisely. His calculations matched planetary observations remarkably. The universe suddenly became mathematically connected. Every planet followed universal physical rules. No invisible angels pushed celestial spheres. Nature required no separate heavenly laws. One universe obeyed one system. Newton began writing his greatest work. He called it Principia Mathematica. The manuscript became enormous and difficult. Every page contained dense mathematical arguments. Newton explained motion with unprecedented precision. He described universal gravitation mathematically there. He showed why planets remained orbiting. He explained tides through lunar attraction. Comets also followed predictable mathematical paths. The universe became understandable through calculation. Yet Newton feared public criticism deeply. Earlier debates had left painful memories. Some scholars attacked his light theories. Others questioned his strange personality harshly. Newton considered abandoning publication entirely. Halley refused allowing that decision. He encouraged Newton through every doubt. Halley helped edit the manuscript carefully. He even funded publication personally. Without Halley, Principia might vanish. Newton finally allowed the book's release. Scholars opened its difficult pages cautiously. Many struggled understanding Newton's mathematics initially, yet its conclusions became impossible ignoring. The laws explained countless natural phenomena. Motion suddenly possessed universal mathematical order. Gravity connected Earth with distant heavens. Newton became Europe's most famous scientist. But fame brought rivalry and suspicion. Other thinkers challenged his discoveries publicly. Newton defended his ideas with intensity. He sometimes held grudges for decades. Genius did not erase human weaknesses. Behind the equations lived complicated emotions. Still, Newton's discoveries kept spreading worldwide. His laws were changing civilization forever. Newton's ideas traveled across Europe rapidly. Scientists tested his laws through experiments. Engineers applied mathematics to practical machines. Astronomers predicted celestial movements more accurately. Navigation became safer across dangerous oceans. Newton's equations transformed scientific thinking forever. Nature no longer seemed completely mysterious. The universe appeared ordered and understandable. Yet Newton never considered knowledge complete. Questions continued growing beyond every answer. He studied religion, history, and alchemy. Hidden manuscripts filled his private rooms. Newton searched for ancient divine knowledge. He believed creation contained secret patterns. Science and faith coexisted within him. His mind explored many mysterious worlds. Some experiments remained strange and dangerous. He handled chemicals without modern protection. Long isolation affected his emotional health. Pressure sometimes overwhelmed his brilliant mind. Still, Newton accepted important public positions. He became master of England's mint. There, he fought counterfeiters relentlessly nationwide. His investigations brought criminals before courts. Newton showed unusual determination beyond science. Later, Queen Anne honored Newton. He received knighthood for extraordinary achievements. Sir Isaac Newton became internationally celebrated. Yet private loneliness remained beside fame. Newton never married or raised children. His closest relationship remained intellectual discovery. Equations became companions during silent nights. Years passed beneath changing English skies. Newton grew older but remained curious. He watched younger scientists challenge old ideas. Some discoveries expanded beyond his theories. Others revealed questions he never answered. Newton understood knowledge always continued growing. Near death, he reflected upon life. He remembered countless mysteries surrounding nature. He compared himself with children playing. A child wandered beside the seashore. Beautiful shells appeared along the sand. Yet the vast ocean remained unexplored. Newton believed humanity knew very little. His greatest discoveries were only shells. The unknown universe remained an endless ocean. That humility became his final lesson. Genius did not mean knowing everything. Genius meant continuing to question everything. Newton died after a remarkable life. His body received honors within Westminster. But his ideas escaped every monument. They traveled beyond Earth toward space. Rockets later followed Newton's motion laws. Satellites remained orbiting through his calculations. Spacecraft crossed darkness using gravitational mathematics. Every launch carried Newton's legacy forward. Yet his greatest achievement remained simple. He connected falling apples with planets. He united Earth with distant heavens. One question changed humanity's entire perspective. Why did the apple fall downward? Newton looked upward and discovered universes. The laws remained even after Newton,